New innovations, upgraded systems, improved technology. Advances in the ironworking industry are constantly evolving, and part of the ironworker's job is to be aware of these changes, to know what's up and coming, and be ready to respond to these changes on the job site. One product that has been steadily finding its own niche has been fiber reinforced polymer composites, otherwise known as FRPs. FRPs are a fast-growing product, steadily gaining popularity throughout the industry. More than $400 million is spent on FRP composites annually, and that figure is rising as ironworkers are increasingly called on to work with this material, skillfully and professionally. Why is FRP in such demand? FRP doesn't conduct heat or electricity. It is highly resistant to corrosion and deterioration. And perhaps most notably, it is stronger than steel and only weighs 1/3 as much. In the past 20 years, there has been a growing use for FRP composites as a replacement for steel. Whether it be a highway bridge, industrial facility, cooling tower, architectural elements, or the average building, many projects are looking for an alternative to steel. In the right circumstances and conditions, FRPs have proven to be the practical choice for owners and contractors. FRPs are most widely used in bridges, bridge superstructures, and bridge decks. With over 500,000 in need of repair, the U.S. and Canadian bridge industries have a heightened interest in FRP as a replacement for traditional steel and concrete materials. The practicality of FRPs include ability to resist corrosion compared to traditional materials, shorter installation period and improved safety for construction workers, lower long-term maintenance and replacement costs, and the useful life extension of existing bridge superstructures with lightweight FRP bridge decks. FRP wrapping of columns and beams has proven an effective solution for repairing and extending the lifespan of bridges. Applied like wallpaper in a variety of layers, FRP wrapping is fast becoming the solution of choice for many states. In California, it is proven not only as a remedy for deteriorated columns, but survived the 1994 Northridge earthquake unscathed. In Pennsylvania, FRP has not only been a good reinforcement for aging columns, but has also become a practical preventative measure to keep out the corrosive de-icing chloride that attacks the steel rebar inside. And in South Carolina, it has been used for repairing a concrete beam damaged by a vehicle's impact. After years of dealing with rusting steel, owners of cooling towers are also increasingly turning to FRP composites. Whether it is new construction or refurbishing existing projects, the desire for a no-maintenance, non-corrosive product to replace steel continues to grow in demand. FRP bars are manufactured by a process called pultrusion. Each bearing bar is made up of vinyl ester resin, glass roving, continuous glass mat, and a synthetic polyester surfacing veil. The rovings are what forms the core of densely packed fibers in the bearing bar, which gives longitudinal and stiffness to the parts. This is the continuous glass mat that is needed to add transverse strength to prevent chipping, cracking, and lineal fracturing. This synthetic surfacing veil is used to keep glass fibers away from the surface. This creates a resin-rich outer layer to give added corrosion resistance and protects it from sunlight or ultraviolet exposure. The reinforcements are pulled through a liquid thermal set resin band, which saturates the material. Vinyl ester resin bonds each fiber into place to give it strength, a corrosion-resistant barrier, and a Class 1 fire retardant rating. After the reinforcements are completely wet out with the resin, the material is pulled through a heated die to produce a continuous, solid part. Afterwards, the pultrusion operation components are then machined for assembly. As FRPs continue to gain in popularity, the Ironworkers International Union will continue to track the latest developments concerning fiber-reinforced polymer composites.